Hi everyone, welcome back to PULLAS Academy. This is physics class for ECET students by Kiran Kumar Adarapu. Today we are going to discuss about part 1 video in simple harmonic motion. Okay, now this is chapter number 6, that is simple harmonic motion. So it is called as S.H.M, simple harmonic motion. The blueprint of this lesson is 2 to 3 marks. So we have to expect 2 to 3 questions from simple harmonic motion. Sometimes 2 questions are repeated, sometimes 3 questions also repeated. That's why you have to understand 2 to 3 questions is the blueprint of the simple harmonic motion. Okay, now in this chapter we will discuss part 1 video. In part 1 video mainly we will discuss about the definitions and examples of periodic motion, oscillator motion and simple harmonic motion. So we will discuss the definitions clearly, and along with the definitions we will discuss about the examples also. Okay na? Right. So this is about today video. Okay na? Right. So let us start from periodic motion. First we will discuss about the periodic motion. What is periodic motion? So actually periodic motion stands here actually if any object is repeated in a regular intervals of time. So in a equal intervals of time any motion is repeated by itself, so that is called as periodic motion. A motion which repeats in a regular intervals of time, in a equal intervals of time. Regular means what? Equal intervals of time. ఏదైనా ఒక మోషన్ అనేది ఈక్వల్ టైంలో, ఏదైనా ఒక ఆబ్జెక్ట్ మోషన్లో ఉన్నటువంటి ఆబ్జెక్ట్ ఈక్వల్ టైంలో మళ్ళీ రిపీట్ అవుతూ మూవ్ అవుతాయి. అంటే ఒక ప్లేస్ నుంచి స్టార్ట్ అయినటువంటి మోషన్ సో మళ్ళీ కొంత ఒక రిక్వైర్డ్ టైంలో ఇట్ ఈస్ కమింగ్ టు ద సేమ్ పొజిషన్, and after in the same equal time if it is reaches to the same time, so the type of motion is called as periodic motion. Simple is called as, so here a motion which repeats in a regular intervals of time is called periodic motion. Just here in the definition, important word is regular intervals of time is the important word here. So regular intervals of time means in a equal intervals of time. Okay, now this is about called as periodic motion. Right, I think you understood what is the periodic motion. So from these examples very easily understood what is periodic motion. I want to explain the examples of periodic motion. So here these are some examples here. So one of the example, motion of the planets around the sun. Actually all planets are revolves around the sun. So actually for example if you consider Earth planet that is revolving around the sun in a 365 1/4 days. That means nearly this is 1 year. In 1 year it completed 1 revolution. Okay, after 1 year again it completes its 1 revolution. That's why the motion of all planets, not only Earth planet, every planet also in a regular intervals of time it is repeated its motion. That's why it is one of the example of periodic motion. Next, one more example, revolution of electrons around the nucleus according to the modern electron theorem. So here what is electron? All electrons are revolving around the nucleus. Okay, now this revolution means what? One of the motion here of electrons around the nucleus is also periodic motion, because they are also repeats in a regular intervals of time. That's why this is also example of periodic motion. Next, one more example is the best example here, rhythmic beat of heart. Our heart beating is one of the best example of periodic motion. Okay, now here so this is one of the example of periodic motion. So next, one more example, vibrations of a violin string periodic producing music. So actually in a violin string produces some vibrations. So these vibrations of violin string producing music. Actually these are producing music. This is one of the periodic motion. This string vibrations is one of the periodic motion. These all are the examples of periodic motion. If you want some more, so one more best example everyone know. So for example, the motion of seconds hand. So the motion of seconds hand or minutes hand, hours hand in a clock, seconds hand in a clock, in any clock or in wrist watch or any watch. So the motion of second hands, for example, seconds hand, it repeats its motion after 60 seconds. In 60 seconds it completed one revolution. That means in every 60 seconds it's repeated its motion. That's why this is one of the periodic motion. Not only seconds hand, if you consider hours hand, so every 12 hours it's completed one revolution. That's why it is one of the periodic motion. For example, minutes hand also, every 60 minutes it completed one revolution. So that's why these all are the examples of periodic motion. In this definition, the important, what is the regular intervals of time or equal intervals of time or similar time. In a similar time any motion is repeated, that is called as periodic motion. Okay na? So one more important about the periodic motion, sometimes asked based on this concept, simple question based on concept oriented questions also asking sometimes. So that's why you need to understood the period, what is the definition also important. Sometimes sometimes question is not asking, but here if you understood what is periodic motion, then only understood the further concept or further derivations is very easily understood if you know what is periodic motion. So each and every concept is interrelated concept. So that's why I want to explain clearly about the periodic motion or any, so oscillator motion and simple harmonic motion. So these are the actually simple definitions, but if you understood these definitions, the next, that means the further concept is very easily understood, otherwise it's not understood. That's why I want to explain these definitions with examples very clearly. Okay, right? So you have to concentrate on these definitions also, because if you understood these definitions, the next each and every point is very clearly and easily understood. Alright, so now here what is important point about the periodic motion? Actually periodic motion is represented by some harmonic functions here. So for example, sine function, cos function, cosine function. So these all are the some trigonometric functions. These trigonometric functions is also called as harmonic functions. So actually this periodic motion is always indicated or represented by these all harmonic functions. That's why periodic motion is also called as harmonic motion. Okay, now what is periodic motion is also known as harmonic motion. Why it is also called as a harmonic motion? Because this motion is represented by harmonic functions. That's why it is called as harmonic motion. So you have to recognize and remember this point. So what is the point here? The periodic motion here, the periodic motion is represented by harmonic functions, represented by harmonic functions. Hence harmonic functions such as sine, cosine, etc. Okay, hence this motion, so here this motion is also known as harmonic motion. Harmonic motion. Sometimes asking what is harmonic motion, write the periodic motion definition. So harmonic motion also repeated in a regular intervals of time. So this is about the periodic motion. Okay, na? Right. Now we are going to discuss about the oscillatory motion. Now we are going to discuss about the oscillatory motion. Right. Oscillatory motion is what is oscillator motion here? So here also it is also one of the periodic motion actually. So but here in this periodic motion actually it repeats. How to repeats here? It repeats to and fro about any mean position. Any motion is repeats to and fro about any mean position, that is a oscillator motion. Okay, so that means a motion, here simple definition, a motion which repeats along a straight line, so which repeats along a straight, so which repeats to and fro along the straight line, about mean position. What is the point here? About mean position. So mean position is also stands for equilibrium position. It is also called as equilibrium position. Or resting position or center point. Okay, na? So these all are called as, so about mean position is called oscillatory motion. Okay, na? So this oscillatory motion is also called as vibratory motion. So one more important word here, it is also called as vibratory motion. That means actually the maximum oscillations is called vibration. If its frequency is maximum or greater, so that oscillator motion is called as generally vibrator motion, but actually both are similar. Sometimes using vibrator motion, sometimes oscillator motion, both are similar. The maximum oscillation, the body is gives maximum oscillations, we call vibrations. That's the difference here. So that means a motion which repeats to and fro. This word is important here in the definition. To and fro. To means what is, for example, if you consider one respect point, that is called as equilibrium position. With respect to the equilibrium position, the body forward motion is called as to motion. The backward motion is called as fro motion. For example, this is mean position. So this is one object is suspended by rigid support. So this type of body is simple pendulum. We will discuss clearly in the next videos. So this is a mean position or center position or equilibrium position. With respect to this mean position, it is moving in forward direction and backward direction. This forward direction is called as to motion. This backward direction is fro motion. To and fro combined is called as oscillator motion. Okay, na? A motion which repeats to and fro along one straight line about mean position. Actually it is with respect to this mean position, with respect to this equilibrium position, it is in motion. So the type of motion is oscillator motion. So actually in our nature we have three types of motions. One is translatory motion, rotationary motion and oscillator motion. Do you know the difference among these three types of motions? Actually if any object is moves along the straight line, that is translatory motion. If any object is moving along any curved line, that is called as rotationary motion. If the object is moves or it is repeats to and fro about the mean position, that is called as oscillator motion. That's the difference between rotationary motion and the translator motion. So this is about the oscillator motion. Clear? So the to and simple is called as, in one word, the to and fro motion is called oscillator motion. Clear? Right. Next here examples. So one of the best example, the motion of the swing. Swing motions are called as oscillator motion. Okay, na? It is moves to and fro about any mean position or any equilibrium position. That's why it is called oscillator motion. One more example, the motion of the branches of tree. Okay, na? So if suppose a monkeys are suspended by branches of the tree, so then the branches of the tree are in motion. That the motion of the branches of trees. Okay, na? So by suspended the monkeys or any animals or any persons, so that type of motion is one of the example of oscillatory motion. So because it is to and fro about one fixed point, that's why it is called oscillator motion. In this way you have to understand so many examples. So this is about the oscillatory motion. Here for oscillator motion also you have to understand some important points. One of the important point is oscillatory motion. Here actually oscillator or vibratory motion if you consider, so that is periodic. Every here point is actually every oscillatory motion, every oscillatory motion is a periodic. This is a what here? Periodic. But every periodic motion is not necessary to the oscillatory motion. Okay, now so that means any object is in oscillator motion, understood, that is also in periodic motion. Suppose if any object is in periodic motion, it is not necessary to periodic motion. Some bodies, this periodic motion is also is also getting into oscillator motion, but it is not necessary. But if it is oscillator motion, it is necessary to periodic motion. Why? Because in oscillator motion it is repeats, to and fro stance repeats, it is repeats to and fro along the straight line here. That's why when any motion repeats, that is periodic motion. That's why every oscillator motion is a periodic, but every periodic motion is not necessary to the oscillator motion. That's an important point. Note this point. And one more point here we have to discuss important is simple harmonic motion. Simple harmonic motion is the special, this is a special case of periodic and oscillator motion. Oscillatory motion. This is a special case of periodic and oscillatory motion. That means special case of both periodic and oscillator motion. That's an important word. Okay, now we are going to discuss simple harmonic motion. That simple harmonic motion is a special case of both periodic and oscillator motion. So actually the topic, the lesson is simple harmonic motion. What is the relation among this simple harmonic motion, oscillator motion and periodic motion? So you want to understand that relation. That's why I want to explain periodic and oscillator motion. After that we will discuss clearly about the simple harmonic motion. Okay, so this is about the oscillator motion. Every oscillator motion is a periodic, but every periodic motion is not necessary to the oscillator motion. It is the important word. Okay, na? In oscillator motion, so actually it is also repeats to and fro along the straight line about any fixed point, any mean position or any equilibrium position. So that is oscillatory motion. Okay, I think you understood what's the difference between periodic motion and oscillator motion. Now we are going to discuss clearly about the S.H.M. Simply is called as S.H.M. Now we will discuss about the simple harmonic motion. Simple is called as S.H.M. Okay, now first I want to explain the definition. But before definition, you want to understand the conditions for a body to be S.H.M. If you understood these conditions, then understood what is S.H.M is very easily understood. That's why I want to explain first conditions for a body to be in S.H.M. After that, we will discuss the examples. Okay, now? So what are the conditions? The first condition is the motion here. These are the very important points here. You have to concentrate here. If you understood the conditions for a body to be in S.H.M, then only understood the body is in S.H.M or not. These conditions are the very important to understood the given body is in S.H.M or it is not in S.H.M. So that's why you want to understood these all points. So the first important condition is the motion. Listen to me. The motion should be in a periodic. The motion should be in a periodic and to and fro along a straight line and about mean position. So this is the condition number 1. That means here if you want S.H.M, so the motion must and should be in periodic. Right? So periodic means repeats in a regular line. How to repeats? It repeats to and fro along the straight line about the mean position. In this way, any motion is repeats, that is called as simple harmonic. That is possible to in S.H.M, otherwise it is not possible. That's the condition number 1. Next condition is also important. So the next condition is acceleration. So here acceleration means A and displacement denoted by x or y. Acceleration and displacement should be always in opposite direction. In opposite directions. Okay now. So if any object is in motion, one of the measurable parameter is acceleration and displacement. They should be always opposite in directions. That's the second condition. Okay now. Next, the third condition is here. This is also. So here acceleration of S.H.M, acceleration of a particle executing in S.H.M is acceleration is always directed towards mean position at any mean position. So the oscillatory object, the simple harmonic oscillator at any position, so its acceleration is always directed towards the mean position. That means the acceleration should be always directed towards the mean position. Next, fourth condition is a very important condition. So for simple harmonic oscillator, at any instant of position, its acceleration is always directly proportional to displacement and opposite in direction. That means the magnitude of acceleration is directly proportional to the displacement, but the directions of acceleration and displacement is opposite in direction. Suppose the acceleration direction is always acting towards the mean position. So the body is moving away from the mean position to extreme position. So the displacement the displacement away from the mean position, but acceleration is acting towards the mean position. That's why they are opposite in direction. From that example you have to understand, that's why these all are the conditions for a body to be in S.H.M. Once again, so the first condition, the motion should be in periodic and to and fro along a straight line about the mean position. Next here, about mean position. Next, second point, acceleration and displacement should be always in opposite direction. Next point is acceleration should be always directed towards the mean position. At any position, at any instant of position of a body in S.H.M is always directed towards the mean position. Next one is acceleration is always directly proportional to the displacement, opposite in direction. So these are the conditions to be in S.H.M. So any object is followed these all conditions, that motion is said to be called simple harmonic motion. That means if a body is said to be in simple harmonic motion, so then the motion should be periodic and repeats to and fro along the straight line about mean position, such that its acceleration is directly proportional to the displacement, opposite in direction, and always its acceleration is directed towards the mean position, is called as simple harmonic motion. In this way define the simple harmonic motion. Once again, understand what is simple harmonic motion. A motion which a periodic motion here. This is one of the periodic motion. That's why a periodic motion which repeats to and fro along the straight line about mean position, and its acceleration is directly proportional to the displacement, opposite in direction, and always acceleration is directed towards the mean position, is called simple harmonic motion, or is simply is called as S.H.M. This is about the simple harmonic motion. So these are the examples of simple harmonic motion. Actually, simple harmonic motion is a special case of both periodic and oscillator motion. That means if any object is in S.H.M, it is also in periodic and it is also in oscillator motion. Okay now. So that means a simple harmonic motion is in periodic motion and also in oscillator motion. That means a periodic motion is not necessary to oscillator motion, but a simple harmonic motion is necessary to in periodic motion. Okay now, a simple harmonic motion is necessary to in oscillator motion, but every oscillator motion is not necessary to simple harmonic. The oscillator motion is follows these all conditions, that is S.H.M. So that means if any object is in S.H.M, it is also in periodic and it is also in oscillator. That is the important point. For simple harmonic motion, necessary to periodic and oscillator motion. That's the relation among these all three types of motions. So examples are very important here. So we will discuss clearly these all examples also. So one of the example is the projection of a particle performing uniform circular motion on any diameter. Suppose any the projection of a particle. So one particle in uniform circular motion. So that particle projection means the perpendicular line on the diameter. So this diameter, that means that is simply called as projection of a particle performing uniform circular motion. So on any diameter is also in simple harmonic motion. That's why this is one of the best example. So we will discuss in the next video clearly about this example. Okay, now next example is the motion of simple pendulum with the small amplitudes. So the simple pendulum motion also we have very important topic. We will discuss in the next videos clearly about the. So just simple understood, the one of the example of simple harmonic motion is the motion of simple pendulum. Next, the motion of loaded spring. What is loaded spring? A spring attached to the load is called as loaded spring. When pulls the string and releases it, then it gives vertical simple harmonic motion. That's why This is one of the example. One more best example is the vibrations of hands of a tuning fork. This pranks means what? Hands of the tuning fork. Do you know tuning fork? This U-shaped device is called as tuning fork. When you applied some external force on the hands of the tuning fork, then this hands gives the vibrations. That vibrations of these hands of tuning fork is one of the simple harmonic motion. They are in simpler. That means they are followed these all conditions. That's why this is S.H.M. That means next one more example, oscillations of a liquid column in a U-tube. If you consider this is one U-tube, in this U-tube if you consider any liquid here, suppose some external force is applied, then this liquid in the U-tube, so it gives vertical simple harmonic oscillations. That's why this is one of the example of the simple harmonic motions. These all are the examples of simple harmonic motions. I think you understood what is simple harmonic motion, what is the oscillator motion, what is periodic motion. Okay na? Once again, so periodic motion means what? A motion which repeats to and fro, a motion which repeats in a regular intervals of time, that is periodic motion. So what is oscillator motion? A motion which repeats to and fro along the straight line about the main position is called as oscillator motion. What is simple harmonic motion here? A periodic motion which repeats to and fro about the mean position such that its acceleration is directly proportional to the displacement opposite in direction, and its acceleration is always directed towards the mean position. That is called as simple harmonic motion. These are the differences among periodic, oscillatory and simple harmonic motion. Okay na? In the next video we will discuss about the different expressions. We will discuss about the displacement, velocity, so many parameters, all important parameters we will discuss in the next videos. Okay na? Have a nice day. Thank you. Bye.